Hello, all. This is episode 27, Deeper Than Dogma. This is going to be on the value of Occam's razor, the law of parsimony. Um, Maybe just a part one. We might have a part two later on. How I'm going to start this out is we have a panel here of scientists, philosophers, or people have philosophy background, people have scientific background, and people have of all other backgrounds. Um, I don't have the greatest understanding of Occam's razor, so we're going to try to suss that out. My basic understanding of it is everything being equal, the simplest explanation is the preferred explanation and the more rational to go with. And I think that's about the extent to that I know it, but from all the talks we've had this week and the past week and the week before that, is that there's a lot more to it. And so to start this off, I'm going to throw it to Maximus Confessus tonight. Let him start us out on that. So if you want to go there, Max.
Cool. Am I edible?
Yep.
All right, cool. Occam's razor, or the law of parsimony, or hashtag Ocky's raise, as we discussed that one earlier, is mostly about a notion of justification. It's a tool that we utilize when going into rational thinking about when exactly do we have a cutoff point for something being accessed, when we have a perfectly sufficient answer. So, for example, we might have a situation wherein we're trying to explain who might have built a fence. Well, if the father of a house is a carpenter, then yeah, he perfectly suffices to answer such a question. He perhaps is the best answer, all things considered. But you might come up with other scenarios, such as maybe his son helped him or assisted him out. He, or maybe his two daughters assisted him, or maybe his wife was assisting him. The extra people need not really count because the first person perfectly answers the question, but they could have still have incidentally have been there. So, for me, when it all comes down to it, I would actually see Occam's razor, once this particular example is given, as something that tells us when an answer is sufficient in itself, and when there are extra factors of a question that are being added onto it have to be justified in themselves. So I see this as kind of a delineation between when a sufficient answer is given and when something which is um, trans-sufficient or extra sufficient is added onto it. Seeing at what point do we have to justify extra sources or extra additions. That's how I've come to see Occam's razor from my own perspective, and I'd be willing to listen to other perspectives. I notice that we have people who have other backgrounds in philosophy, physics, and so forth, and if off kilter on this one, it would be kind of interesting to see how so.
Yeah, whoever has any ideas on that up next, please.
Well, I guess I'll point out what I've learned about it. So, in experimental physics, the way I see Occam's razor is that what you want to do is when you're constructing a model, you want to limit the amount of the vacuous element in the model. So, you construct a model that has exactly the right number of degrees of freedom, and degrees of freedom sort of means that the variables, the parameters that you can vary. So, one of the problems that you can have is that any set of data. So what you're in the lab and you're taking data and you're making a nice graph that has a particular shape. You can literally any set of data can be fitted by a model if you give it enough, if you reduce the degrees of freedom enough, because you can just have an nth order polynomial which fits every single point exactly. But that tells you absolutely nothing about the science behind it. So what you want to do is you want to find the polynomial that has the sort of the highest degree of freedom while still fitting the data within the uncertainty and so forth. And by doing that, what you do is reduce the sort of vacuous element, the irrelevancy. I guess to use a very crude analogy, the sort of thing where you have aliens that come and do all the work and so forth. So you have a model that has sort of enough degrees of freedom such that it's useful, but not so many that it doesn't fit the data.
Yeah, I have a similar experience in my time with when we're troubleshooting problems at work with programming, and when I'm using a tool that a developer's created, and I'll have to whittle down essentially to the relevant pieces that go towards explaining where I think the problem lies. And there's all sorts of additional information that I could include that wouldn't go towards the conclusion. It seems similar in that you have to go deep enough that you can actually explain it, that you can actually point towards something, but not so far that you're burdening the proposition with a difficulty in terms of actually demonstrating it. Or that's kind of been my experience with it in a very practical sense.
I mean, if you have 0 degrees of freedom, of course, it means that your model can only really explain one thing. So you can only explain the experiment that you've just conducted. There's no parameters to vary. You can't use the model to explain anything else. And this is an entirely useless sort of model that we've constructed. The model that only explains one phenomenon. In theory, you can do this with absolutely any set of data, but it's entirely useless. So provided that the uncertainty is not, provided that the data actually fits with the model that you have, you want a model that allows you to vary the parameters so that you can vary a set of parameters. Let's call one of the parameters temperature, and you can say vary the temperature, and then see how that changes the outcome of the experiment. And what you have is you have a model that is useful, that has that you can form an equation with multiple variables that you can vary. I'm not sure I'm explaining this too well. I'm sorry if I...
Well, would this be an analogy? I'm trying to come up with one off the fly, but say I'm loading a truck full of boxes, right? And they're all equal-sized boxes, except for one. And I have a space. I have the truckload's full of boxes. I have one space for one more box. But this box is different sizes than all the others. And I'm trying to find a way to fit this box in that hole. It becomes down to which is the simpler explanation, that this box is too big, or that the other boxes need to be reevaluated and moved around and brought into the equation of me fitting this one box in there. Or is the simpler more thing is finding a smaller box or redoing something just to this single thing rather than the whole of everything else? Or is that just a terrible analogy?
I'm just wondering if someone else wants to speak, because I've spoken a while.
There's an analogy here on the Internet Encyclopedia of Philosophy, which I think is quite good. It reads, oh, sorry, I just lost the page. Well, never mind. Let's see if I can get it back up.
Oh,
Okay,
you're fine.
I can weigh in while you're looking for it, if you like.
Go ahead.
Please.
Okay. Well, the Occam's razor it's a very old principle. I mean, it's attributed to Sir William Ockham, a scholastic philosopher of the 13th, 14th century. It's also called the principle of parsimony. And parsimony, or to be parsimonious, means to do a lot with a little, or to do with as little as possible. That's what it means to be parsimonious. And the principle of parsimony, or Occam's razor, is an intellectual tool that's used in theory choice. When you have competing theories, when you have two theories that you're evaluating, and they both purport to explain a certain set of phenomena. It doesn't matter what the phenomena are. They could be natural, physical phenomena. They could be something like human behavior or a sociological phenomena. It doesn't matter what it could be, an individual psychological phenomena. But whatever it is that you're talking about, whatever the features are that need to be explained, if you have competing theories, how do you choose between the theories? Well, obviously, one theory is going to explain the features in one way using certain hypothetical posits. It's going to posit certain kinds of entities. You know, like for instance, in physics, we have particles and fields of force and electromagnetism and things like that. Right? These are all things that we've come up with, that we've posited. and they make predictions, and because the predictions are successful, we now think that, okay, there's such things as particles and fields of force, electromagnetism, and quarks and gluons and all the rest of it. But these are all theoretical entities that we came up with. Black holes, dark energy, dark matter, all of these things are things that we have posited as explanatory entities to explain certain things that we observe. So there are features in the world that need to be explained, and we have competing theories. How do you choose between competing theories? Well, of course, if one theory makes predictions and those predictions are borne out, that's a good reason for trusting that that theory is on the right track. If another competing theory doesn't describe and predict what you are going to find, as well as another theory, well then it's very simple to choose between those two theories. One theory predicts and one theory doesn't predict. It fails to predict. It mispredicts. So that's easy, right? But what do you do when you have two competing theories that predict phenomena approximately equally well? Supposing you have two theories that predict a certain psychological phenomenon or a sociological phenomenon or a historical event. Two historians are trying to explain why people went crazy during the 16th and 17th century and started burning witches all over Europe. Well, there's all kinds of theories about why that happened. How do you compare these theories, right? Some of these theories actually explain equally well, and they predict things equally well, and they describe the phenomena equally well. But some of the theories are very elaborate. They have just a million things that they have to posit. They have to imagine all kinds of factors were in play that may or may not have been in play, whereas another theory might have fewer theoretical entities. So the principle of parsimony, or Occam's razor, is a kind of fallback position. When you have two competing theories that explain phenomena approximately equally well, or exactly equally well, in terms of prediction and description, what you can do is you can say, well, wait a minute, which of these theories is the simpler theory? Well, why would you prefer the simpler theory? It's not like nature owes it to us to provide us with simple theories, right? Nature isn't out there trying to be simple for our sake, right? And what is actually simple is really just a matter of how easy it is for something to understand. But you don't want a theory that has unnecessary parts. You don't want any fifth wheels. You don't want to have posits in your theory that are redundant or irrelevant, that don't do any explanatory lifting, right? So if you have two theories, and theory A posits all kinds of hypothetical entities, call them X, Y, and Z, and another theory posits a different set of hypothetical entities, call them Q, R, S, T, U, V, so it's got more posits than the other one, but they both explain the phenomena equally well, to the same degree. Why would you go with the more complicated one? You're able to do the same kind of work with fewer posits. And if there are fewer posits, there are fewer areas, there are fewer places where your theory could go wrong. And of course, if you have redundant elements in a theory, if there's a theory that contains hypothetical entities that are supposed to do some explanation, but those explanatory entities don't actually explain. They're just pseudo explanations. It's like a gear that's not attached to anything in the machinery of explanation. Then you should get rid of it, and you should use Occam's razor and just cut that out of your theory. It's redundant. So a way to think of Occam's razor is as a principle that tells you, everything else being equal, when you have two explanations that purport to explain a certain phenomenon, go with the one that has the fewest number of posits, the fewest number of hypothetical entities, the posits, the smallest or the least number of explanatory mechanisms. And that way, you're assuming less in the act of explaining. And if you have any redundancies in there, if there's any irrelevancies in there, cut those out entirely. They don't belong in there at all. So that's the point of the principle of parsimony and Occam's razor. It's for comparing explanations when you've got two explanations that are in competition for the same phenomena. Where it gets dicey is very often two explanations don't try to actually explain exactly the same phenomena. They might overlap. Theory A over here might be trying to explain these phenomena. Theory B might be trying to explain these phenomena, and they overlap. And then you say, which one will you choose? But then then you can't use Occam's razor in quite the same way. You can't appeal to Occam's razor there. It's not quite so tidy because they're not explaining exactly the same phenomena. They're explaining different phenomena, but they have some phenomena that, in common and that overlap that they both try to explain. But then you won't be able to appeal to Occam's razor there. It's not as tidy. So Occam's razor is the principle that everything else being equal, when two theories are trying to explain the same phenomena, you go with the theory that makes that has the fewest number of assumptions. That's the idea.
Could I briefly make a few points on this, if that's okay?
Yeah, please go, and then Alex wanted to comment after you.
I thought most of that was fine, and but there are a couple of things that I'm not too sure on. I think the most important point that I'm going to bring up here is that you can get situations where you have two different theories or two different models that both predict the same phenomena. They both predict it equally well. One is far more complicated than the other, but physicists actually use both, and they don't actually see a need to dismiss one over the other. I looked on. I've got a few of my own examples, but I looked on Wikipedia, and there's actually a much better one that Wikipedia gave. And Wikipedia compared the Newtonian mechanics with Lagrangian mechanics, and I've done both, so I'll try and briefly explain what the difference is. Newtonian mechanics is probably something you've all heard of. It postulates a world where objects are controlled by different forces. Now, Lagrangian mechanics it makes exactly the same predictions as Newtonian mechanics. It's essentially more or less the same thing, but the model uses this very interesting object called Lagrangian, and it's quite difficult to actually explain what the Lagrangian is because it doesn't really make much physical sense. It's something like the potential energy minus the kinetic energy, something like that. But the point is that the Lagrangian formation is actually far more complicated and far more difficult to understand than the Newtonian formation, and there's it is not just mechanics. I mean, there's another example like in quantum mechanics, you can think of things in the Schrödinger picture or the Heisenberg picture, etc. But the point is that there are often two different pictures, and you don't see a need to use Occam's razor to dismiss one because they both have utility. So there's no reason to pick one over the other. Lagrangian mechanics happens to be better at solving some problems, particularly the more difficult problems. The sort of you might have heard of the idea where you have like a pendulum on another pendulum, a sort of chaotic system. Lagrangian mechanics is probably better at solving that sort of system, whereas Newtonian mechanics is probably better at solving a system where you've got a ball rolling down a hill, a more simple system. But the point is, you don't use Occam's razor to dismiss Lagrangian mechanics. It's not necessary, and I think the distinction to be made here is that when you would use Occam's razor to dismiss a competing model is when that model, like you pointed out, has this sort of degeneracy, this irrelevancy, or as I mentioned earlier, when this model has too few degrees of freedom, where it doesn't have the sort of flexibility that the other model has. But there are plenty of occasions. I'm not sure if I'm talking past you. You might actually agree with me on this. I'm not too sure, but there are actually many occasions when Occam's razor can be misleading because you don't actually want to use it because both theories work equally well. And I mean, I think there's a slight thing where you have to be careful there. Anyway, I've rambled on way too long. I hope I made some semblance of sense.
Could I speak to that just briefly?
No, please.
Yeah, go ahead, Oliver.
Quantum, when you were describing that, at one point you said that that you use both these models to explain somewhat different phenomena. That's a case where you wouldn't apply, where you should not apply or invoke Occam's razor, right? That's sort of one of the things I was trying to get at in my little exposition earlier. If in physics it happens all the time where we have two models, they explain some of the same phenomena using the two different theories, but they also explain a host of different phenomena independently of one another. So theory A explains, this set of phenomena, theory B this set of phenomena, and they overlap a little bit, or they might overlap considerably. But in fact, they don't purport to explain. They're not theories of the same things. There's just some overlap, and in a case like that, you really can't apply Occam's razor. There's no point in sort of trying to adjudicate, well, which is the correct theory, because this theory does very well for these phenomena, this theory does very well for those phenomena. There might be you might be tempted to sort of choose between the two theories because the theories might be mutually incompatible. For instance, there might be posits in this theory that are incompatible with the posits in this theory. They can't both be right. So at some point you might think, well, one of them's got to be wrong, or maybe both are wrong. Maybe some other theory is right. But in the case that where there isn't even an inconsistency, if they're not explaining the same phenomena, if they're not directed at the same phenomena, there's no reason to invoke the principle of parsimony or Occam's razor. Occam's razor is there to eliminate redundancies and irrelevancies, explanatory fifth wheels from your theory, and it's also there when you have two theories that purport to explain the same phenomena, but one does it using fewer assumptions than the other. But if they're explaining different phenomena, as you described, then you shouldn't even be tempted to invoke Occam's razor there.
The thing is, though, that and I was very careful to use this example because obviously the go-to example is special relativity versus Newtonian mechanics, and I was pretty careful to choose this one,
right.
Because it actually is the case that both do explain exactly the same phenomena. You can use Newtonian mechanics to explain the sort of double pendulum, and you can use Lagrangian mechanics to explain the ball rolling downhill. Both do exactly the same thing, but both theories are independent. I mean, they are different types of theories. The Newtonian is about forces, whereas Lagrangian is about this thing called the Lagrange function.
Okay, but forget what they posit and how they explain. The question is, what is the object of their explanation? Do they explain the same phenomena, or do they also explain different phenomena? If it's different phenomena, then you shouldn't even be inclined to invoke Occam's razor. It's only
they explain the same phenomena.
Okay, well then that's an occasion where you can say, okay, well, let's see, can we in fact eliminate one theory using Occam's razor? But very often you can't. Very often, if both theories explain equally well, and it's not apparent at all which theory makes more assumptions than the other, right? Sometimes they don't. Sometimes you have two theories. They both have a virtually identical number of posits, of assumptions. Then there's no basis for using Occam's razor. This is one of the things. Occam's razor is actually hard to apply in actual practical cases. It is seldom the case that you have two theories that actually are addressed at one set of phenomena, and it's the same set of phenomena that they both address, such that you can then compare and see if one of those theories has redundancies, or one of those theories makes more assumptions than the other.
I think something I wanted to. Sorry, I'm gonna jump in because, like, otherwise we're gonna go back and forth between the science and like I'm much more comfortable in this where we've gone here, and this is why I wanted to bring it up, which is this. Is it a problem for the principle that it doesn't speak on notions of truth, so that you can, as we've had demonstrated, have two theories that are separate from each other and yet explain the same phenomena. Does that in fact invalidate using such a theory? Like, it comes down to, once again, like I was querying why we value it above, like why we naturally tend to implement it when it holds no apparent truth value.
If I could follow up with that too, I think the very idea of using the principle of Occam's razor is a little naive when it's been utilized in so many different ways by so many intellectuals over the course of history. It is true that there is one general idea which is invoked by Occam, which is actually used in his metaphysics, so he takes it to be very strong to his philosophy. But when you say the Occam's razor or the principle of parsimony, I think it's best to stipulate what you mean, first of all, because it has been used for so many different places. And I am curious, as a extension of Alex's question, where someone brings this into their epistemology, because there's, for example, someone like Occam who uses this to sort of reject Aquinas' system and try to come up with his own. There is Stephen Hawking, who apparently attributes quantum mechanics, its discovery, to Occam's razor. There's all these places where it pops up in history, but it's not exactly the same every time. And if we're merely talking about science, that's going to be a little bit different than if we were talking about maybe more generally induction, or if we're talking about epistemology as a whole, so on and so forth.
Yeah, I'm not sure if Quantum wanted to jump back in there, or can I bring some of the other people in on the panel if anybody else has any ideas on what's going on here?
Yeah, I could speak to. I think I could speak to what Jimmy said there.
Yeah, please.
Considering that there are many philosophies regarding Occam's razor, it seems that one does have to define their terms and what they usually mean by it. Occam, as Jimmy said, did take the law to have a lot of metaphysical implications, and of course was very rigorous with its implementation. However, it seems that when Ozzy and Quantum Overlord went over this, it was mostly about theory selection, two competing theories, choosing between them when they seem to answer sufficiently what's going on, but posit two different sets of explanatory tools. And of course, when it's laid out in these terms, it seems that it could be taken out in terms of simplicity, or in terms of weeding out pseudo explanations. I've also seen Occam's razor. Posited, and I actually kind of prefer to see it in a way of as well probability, considering that you have already something to suffice explanation. What is the additional probability of adding other explanatory tools, categories, entities, so on and so forth? So there also seems to be that approach. I'm also kind of curious as to how other people would see it. For my own perspective, I take it as kind of trying to delineate between when something itself is already sufficient, and when would you want to add on, or if you even do in fact need to add on extra entities within one theory. So I started off seeing it in this sense. Does anyone else want to speak to this difference as well?
Just jumping in here. Often I hear people in my conversations on Google Plus will often bring this principle up as if it is a very, very strong, fundamental, and broad category of epistemology in general. I've discussed many times, especially as I am a Christian, and I am constantly speaking about apologetics and evangelism. This rule, this Occam's razor, the principle of parsimony, whatever it be called, often comes up and is used as a general rule of epistemology. And I think that it's worth noting that that's to be defended. I think that's something that needs to be put into question, because where you put this rule, whether it is within the bounds of science, whether it's prescriptive at all, or just a matter of preference, as was being questioned on the tab earlier, whether it's a matter of abductive, not merely predictive or retrospective, retroductive forms of reasoning, all these sort of questions. Where does this rule fall into your epistemology? What part does it play? How fundamental is it? Questions like that. That's what really interests me.
Yeah, I think along those lines, it certainly doesn't tell you what is the case, right? But it might recommend belief along a certain line. And I think all too often it's abused when it's used to kind of cast out an entire thing out of hand in a maybe in an unjustified manner. I wanted to go back just for 1 second. Was the I think it was Max was talking about that, like I'm far more comfortable with the application in terms of you have a given, like I have a given hypothesis or a proposition with extra premises, and it's a way of vetting my own propositions such that I'm removing things that don't go towards the conclusion, and maybe that's not Occam's razor, but it seems to me like a variety if you were to compare those as two theories, where you have a stripped down version and then you have the version with the extra premises that I feel far more comfortable about that than I do about casting out an entire other, you have two theories that are entirely different, both of which are claiming to explain a given phenomena and tossing one out, if that makes any sense.
It does, and this probably is going to be a little bit of a distraction, but I hopefully not too far, which is the argument that seems to be going back and forth, and I want to bring this in as well to discuss, which is this idea of anti-Occam, or anti-razor, sorry, which is when you haven't reached your conclusion, and essentially the idea is that if the premises that you hold do not reach the conclusion, then you are justified in adding additional premises, and is such counter to the nature of Occam's razor. And it seems like we value that just as equally. This idea that there may be necessary steps that we have to keep adding on, essentially.
Yeah, well, it seems like that line of thinking actually as you're going through Occam's, and maybe I'm abusing the term, but as you're going through it, that it can lead you to that, where, I have an example I've shared with some of you in terms of talking about a certain phenomena that I explained through a list of premises that lead to a conclusion, and then a Christian friend of mine says, well, I agree with all of that, I just believe that God created the universe that created those processes. That would need to be fleshed out. That's something you could put out there, but as you're saying, it's an indication that there's missing steps there, breadcrumbs to take you to the conclusion. I don't see that one being simpler in that case means that that it goes towards veracity of the claim at all, for the more simpler one.
Well, I know there is a distinction, and for the simpler, the nature of it being simpler, isn't there? So it doesn't necessarily follow under what is simpler, due to the nature of simpler being very subjective.
Well, no. It would be the simpler that has the full explanation, right? Not just the simpler, but it would have to fully explain. It would be the simpler one that can fully explain, not just the simpler one that has some explanatory power.
Yeah, I think this is something which quite easily gets confused in Occam's razor, which is the idea that simplicity is beauty and therefore its beauty is truth. And that simplicity is completely different to the Occam's razor simplicity.
Well, I think
that's the main area of confusion that I hear. Something looks more beautiful, therefore it's more likely to be true. That's just artistic. There's no logic behind that.
Right. I think that's where problematic notions come into play, because I think when people think simpler, they think, well, what's going to be the simplest thing? A being that can do everything. Everything is now explained. It could not be simpler. And I think that gets the notion of what is simple is misconstrued in that sort of idea, essentially.
Right.
Where a being that can do everything is not so simple, or is not as simple as
everything is not explanatory. Ozzy?
Yeah.
Yeah. Well, first of all, positing a being that can just do anything is in fact not a simple explanation. In fact, it's not an explanation.
Well, the explanation is the explanation for such a thing would be, or why does X exist? Would be that a being capable of creating it created it.
Right, but that's not an explanation. That's a stipulation. That's simply insisting that there exists something, some X, that has properties unspecified, that are sufficient to explain what needs to be explained. But that's a pseudo-explanation, right? I mean, how did this beer glass get full of beer? Well, there's this thing in my kitchen. Okay, I'm going to call it a quatlu, and it's capable of filling beer glasses. Well, how does it do it? What exactly is this thing, this quatlu? Oh, I'm not going to specify anything about it. I'm just going to say that it has beer glass filling properties. It has, that's not an explanation. That's a pseudo explanation.
I love that.
So we have to guard against that, because you're right. There's a tendency. A lot of atheists are very happy to sort of dismiss God and theistic explanations by appeal to Occam's razor, because they think that those explanations are always necessarily vacuous. Now, I agree that a lot of theistic explanations are just completely occult and mysterious and vacuous, and therefore pseudo-explanations, in which case I think you can use Occam's razor to get rid of them. They're redundant. They're not explaining anything. You're just invoking an entity and saying it has explanatory power without actually giving the explanation. But not all theistic explanations are like that. But of course, when people do make that mistake, then of course, yes, you can invoke Occam's razor. So, and I think it was Alex who was making the point, and Simon, you were also making the point about simplicity. People can confuse simplicity, the notion of explanatory elegance. They confuse that idea with explanatory power. The fact that something is simple and elegant doesn't mean that it's more likely to be true. That doesn't indicate veracity. That's what I meant when I said earlier that nature doesn't owe us simple explanations. Right? The truth could be complicated. It might just be that the truth is, in some instances, very complicated. There are lots of factors. There are lots of there are lots of entities involved in the explanation. Right? Sometimes that's the case. In other cases, the explanations are simple. So you cannot just appeal to simplicity and say this theory is simpler than that theory, therefore that's the truer one. You hear that all the time. Occam's razor says that the simpler theory is the truer theory. That's completely wrong. Everything about that is wrong. Nature doesn't owe us simpler explanations. It's a mistake to assume that the simpler explanation will be the correct explanation. What reason is there for thinking that a simpler explanation will be the better explanation? Right? The reason we favor simpler explanations is we want to get rid of the redundancies, the pseudo-explanations, the fifth wheels, the pieces in our explanatory machinery that aren't doing any work. They're just these fifth wheels that are just spinning around. They're like gears not attached to the rest of the machine. They're not doing any lifting. They have no explanatory power. We want to get rid of those, but also we want to make sure that our theory doesn't posit more than is necessary when compared to another theory that might explain the same things with fewer posits. And what's the advantage of that? That's prudential. That's just a matter of prudence. Try to assume as little as possible. There are fewer landmines that are going to blow up, and you're going to find out, oh, that theoretical entity doesn't in fact exist, or that principle doesn't in fact operate here, or something like that. So there are prudential reasons for preferring a simpler theory that will govern theory choice, but that can't be very, very high in your epistemology to address Jimmy's concerns. It seems to me that the principle of parsimony actually has to be fairly low. There are going to be all kinds of other considerations that point to truth, things like accurate description, prediction, things like that are truth conducive. These are what epistemic virtues. These are not pragmatic virtues. One should think of Occam's razor as a prudential or a pragmatic virtue that guides theory choice, but that should not be very high in your epistemology. I think it actually needs to be fairly low, a kind of fallback position, a kind of something you resort to, everything else being equal, when you've applied all of the principles that do point to the veracity of a theory, and you've got two competing theories that seem to be on the table and both viable theories. Then you want to say, well, where am I going to go here? Which one should I invest with more confidence? I'm going to go with the simpler one here because it posits fewer things. I have to assume less. Fewer things can go wrong or be falsified. I'll go with that. But that doesn't mean that theory is right. The truth can be more complicated than you thought. You might find out that it's wrong. So you can't just outright dismiss a theory using Occam's razor, as I see it.
I think
Okay,
too
so
that. Sorry, go ahead, Sam.
no, well, I was just going to follow up on that by saying, so in some practical sense, then, really Occam's razor should be used to order theories, i.e., we better look at this theory first, then this theory, maybe then the next one. That might
That's
be a
very right.
practical use of it.
Yeah, that's a
And
very
then-
good way of putting that.
And then, so, yeah, so Jimmy, you go ahead. I'll think of the other thing.
Can I just, sorry, I missed some of it, but I think I got the general gist. I'm just wondering if this happens in practice, because I can't really think of a situation in physics where it does. The part about not accepting just because a theory is simpler doesn't make it right. I mean, I agree with that, of course, and I pointed out earlier that in the chat that there's a certain irony with regards to all this, and this is not to say that Occam's razor is in any way invalid, but there's a certain irony in that theories actually tend to get more complicated and not less complicated. So the frontline theories for explaining the universe have 11 dimensions and ridiculously complicated levels of mathematics and so on. So that's sort of an irony thing, and it's not that Occam's razor is invalid. It's just that you can't use it to say that the simpler theory always works, which I guess is subtly different. But with regards to ordering the theories, I still find that a little bit dubious, because I'm not sure that it does that. It does that so much in practice. It just seems to me to be the model that has the most parameters that you can vary, so to speak.
So the other point I wanted to make on the back of the idea of ordering the theories is that, you know, we would do that in a practical sense when there is data still yet to come in, which we could, you know, interpret and apply. Of course, but when we're talking in philosophical terms, we're not ever really talking about receiving future evidence. So is there some way in which that changes the preference for theories or models that we have in philosophy?
Well, so this is exactly the sort of thing that I was about to get into. So I was going to say that just to provide an example, in distinction from what Ozymandias was suggesting, not in raising our evaluation of the principle of parsimony or whatever it is, but rather in asking why we're using terms that seem to me to be drawn within the bounds of scientific methodology. Like it is true that perhaps, or I should rephrase that. Perhaps for Ozzy and others, and this includes myself, the principle only plays a part in scientific methodology. But then I wonder then, perhaps we should make a distinction between explanations and theories, because they're not actually the same thing. It very much depends on your philosophy of science. For me, as an instrumentalist, I don't make any commitments to the ontologies posited by a given model. I simply think that the model is useful. And moreover, I don't think that the model explains anything. I think that it simply has useful predictions for everyday life. That may seem kind of alien at first glance, but I think there's reasons for thinking that over going for a scientific realist point of view. But when we talk about certain ideas or models or explanans explaining things, there is a broader category of abduction there than merely what's found in scientific methodology. And I wonder, okay, are we actually talking about explanations in themselves, as in, from my point of view, an explanation would be something that satisfies the principle of sufficient reason. It might be something else to somebody else. Or are we talking about scientific methodology, where very specifically we're talking about the scientific method. We're talking about steps of the scientific method and a basic principle that is to be applied during or as part of one of those steps.
Well, and that kind of leads into what we don't have to get to it right this second, but I want to get to it soon. Is when to use Occam's razor? When are the good points to use it? I know we discussed it a little bit of when competing theories and things like that, but I also want to discuss when not to use it, because I do hear it misused a lot on at least our corner of the Google tubes, as I think Ozzy had said, as like a trump card. Like, here's Occam's razor, mine's simpler, bam, I win.
One of the most common kind of, and I've been guilty of using this example myself at knocking Occam's razor is, well, on Occam's razor we should all be solipsists because that posits the least amount of entities, which
Right.
is just
Right.
you. But really, really I could just respond that solipsism isn't in fact sufficient. It isn't explanatory. It doesn't capture our everyday experiences and knowledge. Mostly because it doesn't encapsulate why our memories are so predictive. Why are there other things that behave so much like us and exemplify the same things? I could just argue that there are tons of things that it doesn't suffice to ground on first glance. So the explanation itself has to be first and foremost sufficient, which is what people don't get. Another thing, a mistake that I find people don't get is what a friend of mine labeled the timeless theist fallacy, because there was a YouTube user, the timeless theist, who constantly misused Occam's razor in such a sense. He said something along the lines of, imagine on idealism, the notion that only minds exist, you only have to posit one such substance, which is the mind. Whereas, so this is kind of why in quantum, and if this is the case, then it would explain quantum mechanics quite nicely, because apparently when the particle splits and because it's observer dependent, it's based on the observer, whereas with multiverse theory we have to posit all these universe entities. So do we really want to posit one kind of thing, like ideal minds, or universes? Well, someone could easily say that, well, no, false dichotomy there. First of all, an entity, while they both have the same explanatory power, you could reason for why there would be a multiplicity of entities. Maybe universes are a lot easier to explain than immaterial minds, which could be very hard to square with what we know of psychology, what we know of biology and physiology. Not to mention, we could say, well, we've at least witnessed a universe. We've never witnessed a mind living independently of a body. So
Well, that goes off that, like, if I were to take it, my mind is the only mind, and my mind creates all the mental stuff. Would that not fit in? I know that's kind of what you're saying, but would that
well,
not?
the point is, you could argue that solipsism wouldn't suffice in itself to explain other phenomenon, thus not making it sufficient to be counted as a single entity, thus needing to posit more entities, such as an external world and other minds.
Well, that
But
brings.
then wouldn't the just to put
Hold on,
sorry,
that brings the. I'll let you go just a second, Saga. That brings in the question that I've always had of and I'm sure you guys are smart enough to answer, is if I were to use Occam's razor on any type of god or deity with all these powers, is Occam's razor. Explain how Occam's razor says that it would have to be one entity with all these powers instead of multiple entities with maximal single powers.
Well, I think one of the things too is that with Occam's razor is not how you get from point A to point B in the fewest amounts of steps. It's getting from point A to point B with the least amount of assumptions out there. So when we're talking about from solipsism, the assumption that you're the only mind, I think, can be held in equal regards to the assumption that there are other minds out there as well. I don't think that one of them is necessarily a shortcut or necessarily less assumptions than the other one. I don't think that saying that, okay, if we all subscribe to Occam's razor, we'd all be solipsists, because I think that the assumption of us being there being other minds, and the assumption of us of there only being one mind, are equal assumptions to begin with. Not one of them isn't stronger to start with than the other one.
See, I don't know that I agree, because I think even God, even if I posit God and that we're all mental stuff of God, that still narrows down Occam's razor to one entity that has the most explanatory power. He's one God that explains everything, because we're all mental I don't want to use the word figment of his imagination, but we're all mental stuff of this one God that has the most explanatory power.
Well, just to throw this in as a wild card, wouldn't a simpler theory still be that there is no what's the correct word? Sufficient justification, and we reduce ourselves down to nihilism. This idea that why would that not be a simpler answer?
Well, it's not. I think it's not about what's the simpler answer. It's what's the answer with the less amount of assumptions.
Well,
and I think
that's
that's the point that's the point that a lot of people conflate when they're talking about Occam's razor.
But that in itself has
Alex, it would be the less amount of assumptions with the most explanatory power. I think. Am I right on that, or?
Well, one assumption, there would be one assumption, and the assumption would be that there is no explanatory power. So how, I suppose, is that Occam's razor in such a case isn't really valued?
But if I could point out here, I think also what is meant by assumptions. We covered this already, but it's a little bit of a slippery slope when it's worded like that, Sokka, because first of all, what you take to be an assumption is disagreed upon by many individuals, but also what you mean by that which is assumed is different. Like, do you mean the amount of propositions that could be used to describe the view? Do you mean the amount of base ideas that are in the view? Do you mean the objects that are assumed by the view? Do you mean the metaphysical entities, principles, or causes that are, like, what do you mean by assumption? That's a very, while that term is used very often, I think.
Explanatory entities is what we have to talk about, right? If we're comparing explanatory theories, then what we're talking about here, what we're comparing, are the number of explanatory entities, not the number of propositions that how many propositions it takes to explicate the theory, to express the theory, but what are the theoretical entities? What are the principles? What are the operative causal entities and principles in your theory? And someone brought up I think it was Xbox brought up the example of, well, what happens when you posit one big thing that has a lot of powers, a lot of principles, a lot of capacities to explain a certain set of phenomena, and then you posit a lot of little different things, but each one has only one ability. So you posit one God that has all these abilities, and he can do everything that we see, or you posit a bunch of simpler gods that are lesser gods, that have much less power, but each one has the power sufficient to explain the phenomena when considered jointly. Which is the simpler theory? Well, there I would say that the theories are actually, as described, are equivalent. You're positing more objects. You're positing many gods versus one god. But the explanatory entities are the same, because this one God has all these powers, and then in the other case, all of the little gods each have one power that do the work of the one God that has many powers. There, I would say that the explanatory entities in question, the principles in question, are the same. We just carved them up differently. So this goes to your point, Jimmy, that it's actually not a tidy business deciding which is the simpler theory, which is the theory that has the fewer posits. It's not at all clear. You have to sort of do a bit of work to think about these things.
Right, and if I could throw a monkey wrench in that description, I wonder if people are going to disagree with good reason, even after talking about these entities being located within the category of God versus outside of that category, because different people are going to conceptualize God as, for example, within the Christian metaphysic could be divinely simple, right? So these entities are not really entities of any sort. It's just one entity, even in its even for explanation's sake, even for being an explanans. So even in the way, like you use the word, even in the way that we carve it out, I think that your more fundamental epistemological commitments are really going to put you at odds with how other people use the principle in question.
Yeah, I take your point there. Although I think that there would be arguments that one could bring to bear against the idea of divine simplicity. I think that divine simplicity is an ontological simplicity. It's not an epistemological, explanatory simplicity. And what we're talking about here is an explanatory principle, a principle that we bring to bear in theory choice with respect to explanation. So one could still posit the doctrine of divine simplicity. One could still accept the doctrine of divine simplicity, but still grant that as an explanation, there's nothing simple about it. That there's still a lot of explanatory entities. You know, like if you talk about omniscience, if you talk about aseity, if you talk, you know, whatever the causal powers of God are, for instance, the fact that you can specify what they are, even if they are ontologically all inhere in one substance, you know, the divine substance, right? That doesn't change the fact that your explanation has a lot of moving parts, and therefore there's a lot of assumptions, and you could be going wrong at any particular point in there. So I still think you could apply Occam's razor there, even if you accept the doctrine of divine simplicity.
And I think if you applied Occam's razor, if the choices are God or solipsism, I think I could make an argument that solipsism would win out over a single God, for
Right.
the reason that you're saying. And I'm not promoting solipsism. Everybody knows I'm not a hard solipsist, but I think if those were the two things, that the solipsism would win out every time.
Yeah, I would argue that neither one of those is an explanation at all. Which is one of the abuses of Occam's razor, actually. We're alluding to.
This was the question that I kind of asked a while back, I think, which is to say that you know, it's fair enough that we can postpone judgment and therefore order theories, etc., when we expect data to come in. But when we don't expect data to come in, okay, that's when, you know, I would use Occam's razor in this philosophical sense to discount extra entities which are posited, which don't have, which can't, you know, nothing's going to be proven in the future. So it's not like this is going to, you know, decide the dispute. But it seems to me that it's more reasonable to posit less, to make less assumptions when we're trying to think about things in philosophy. I mean, that seems to me the principle that we should be using. So it's just about making those, you know, fewer numbers of, what am I trying to explain? I put it as a question last time, which was much better for me because I wish to ask it as a question. So when in philosophy can we say one philosophical idea is better than another based upon Occam's razor? Are there any instances where that could be the case?
I just wanted to poke in something real quick with this notion of
that was the question.
I don't think, from what I understand of this
hang on
notion
just
of
a second,
truth.
Alex. Can you hang on just a second? Can you repeat that, Simon? I'm not sure that I grasped what you said.
Okay, so what I'm kind of saying is in physics, yes, I can see quite easily how we can use Occam's razor to, you know, to pare down theories in order to, as Overlord said, to choose the minimum number of variables needed to explain any given observation. That doesn't seem possible in philosophy to me. So it's not the same use as we've all been saying of Occam's razor. So what I'm trying to pass out is how in philosophy can Occam's razor be used? Is the number of variables the same criteria that we're looking for?
Well, I would say yes, we can.
I'm really struggling here, actually. I'm sorry. I'm not trying to be difficult. I'm just trying to get this in my head. I mean, I don't understand why it would be any different when, say, applying this to the idea of a god or something along these lines.
Because there's no proof. As far as I can see, that's quite a major difference. Or there's no expectation of proof.
Well, that wouldn't matter. Remember,
I've lost you, Ozzy. You're quiet for me.
Yeah, Ozzy, you've dropped your sound.
I've lost you, Ozzy. You're quiet still.
No, Ozzy, you're not coming through at all.
Your video's still playing, but your mic's dropped. Okay. He said he'll be
It
right
may
back.
be your wire because you moved when it cut out.
If you want to try to fix that, I'll let Alex go since I cut him off just a second ago. I just wanted to make sure, since I had an issue with and couldn't understand what Simon said, I wanted to make sure. I figured someone in the audience didn't either, so I wanted him to repeat it.
Well, I think I might have like where its usage would come in. I think you would be in the philosophical sort of sense. You would have to create basically an internalist analysis, right? So let's take the notion of the one being with the many attributes, as opposed to the many attributes explaining the many phenomena. I think where you would use Occam's razor is you would reduce essentially the attributes to what is necessary, as opposed to what is conceivable. And I think that's where you would find it.
Yeah, this is where I'm trying to get to. Yeah, what are the philosophical terms that we could use? And Ozzy, are you back? Can you?
Yeah, can you hear me all right now?
Yes, way better.
Okay, sorry about that. In any explanation, doesn't matter if you've got evidence for the explanation or not, you're using Occam's razor precisely in those cases where you don't have evidence that would allow you to choose between the two theories. I mean, wherever you have a piece of evidence that points in favor of one theory over another, well, that's where you go. You go with because evidence, description and prediction, and consistency, logical internal consistency. These are all things that help us point in the right direction, or rather, inconsistency tells you you're going in the wrong direction. Consistency doesn't tell you anything. But when you have a description or a prediction, so when you have data that point in the direction of a theory, that you go with that. Okay. Where you use Occam's razor is precisely where you don't have results that bear on which theory you should choose. Then you're saying, okay, well, now what am I going to resort to? I've got these two theories. They both predict and describe the phenomena equally well. Now what the hell am I going to use, right? They both explain the theory. The theories each explain all of the phenomena, but they explain them in completely different ways. They posit different hypothetical entities. They invoke different causal principles. How am I going to choose between these two things, especially if these two theories are incompatible? They can't both be right. What am I going to do now? That's when you go, okay, Occam's razor. Let's see here if there's one of these theories that has some redundancies. Get rid of those. Okay, in either theory. And then I'll finish the point. And then what happens if there are no redundancies in either theory, and that is the theories both posit all and only what they need to explain what they explain, but one theory makes fewer assumptions. Well, then, just as a matter of prudence, you should go with the one that makes fewer assumptions. That doesn't mean that that theory is true and the other one has to be false. It just means that everything else being equal, you're on safer ground with this one. And so, provisionally, you can throw more weight and more confidence, and perhaps invest more investigation down that avenue rather than the other avenue. But further evidence might point that no, you went down a blind alley there. You should have gone the other way. The more complicated theory was the right one after all.
Can I just sorry? Can I very briefly ask, because I think most of this is we're in broad agreement, but I think it would just really help me in particular if someone could come up with an example where this is really been useful. In terms of where you have two competing theories and you use Occam's razor to pick one of the two. I mean, I just really appreciate an example that we can sort of argue with.
Are you talking in philosophy or
in philosophy or?
Well, in physics. So I mean, in science, in something where we can say this has worked. We've chosen theory A over theory B. We know.
Okay, it doesn't work that way. It doesn't work that way. You're never going to see a case where all of the physicists, or all of the historians, or all of the philosophers, or even most of them, operate using the principle of parsimony. The principle of parsimony is an epistemological tool that we should use, that all too few people do use. Right? It is a desideratum, a desirable thing to use in theory choice. Unfortunately, there is no field that I'm aware of where people, in fact, say we're going to go with this theory and not that theory because this theory makes fewer assumptions. Right? You're always going to see some scientists or some historians or some sociologists or some psychologists or some philosophers who are trying to explain something go, I'm going to go with the simpler one. And you're going to still have a whole bunch of others who are going to go with the more complicated one that makes more assumptions, either because their intuitions guide them in that direction, or they judge the theory to be more fruitful. That is, they think, perhaps it's a newer theory that's more full of promise. In other words, there are all these variables in theory choice. Occam's razor is one of the variables that people use. It is not one of the ones that is very, very high in people's epistemological ranking, in their index of epistemological priorities. And so to ask, give me an example where this happens, or I can point you to individual people who will choose one theory over another. But you're not going to find a consensus that way because there isn't a consensus on the importance of Occam's razor. And because it is kind of low in your priorities, and I think should be low in your priorities, we should never expect that people are just going to go, look, oh, this one's simpler than that theory over there. This one makes fewer posits and assumptions than that one over there. And then sort of the body of researchers in a discipline go that way. That we're just never going to see that happen.
I really don't understand why not. If
there are other
consensus. Consensus isn't just one person goes one thing becomes another. We generally do come to a consensus in most fields about something. I'm just wondering if you can give a historical example where this is proven well.
I just explained why you'll never see it. I just explained why you will never ever find that the consensus will be swayed on the principle of parsimony. That will never happen. It's just
Can Sokka add something in there? He's been trying to jump in on that, and I think it's on this point. So can you give him just a second to jump in?
Yeah, I think that when we talk about Occam's razor, I think that in the sense of explanations for things that you see every day. A good example would be the golf course example. Is you tee off, you're 300 yards out, you hit the ball, and you approach the green later on, and you walk up and you see your ball's in the hole. Now, obviously the most simplest explanation is you actually drove 300 and some odd yards and managed to get a hole in one. And that's what most people are going to think. They're not going to immediately jump to the conclusion that maybe it fell in the fairway or just off into the rough, and a crow came along and picked it up and started flying over the green and then dropped it and landed right into the hole or beside the hole where a groundhog ran across and knocked it in. People aren't going to go to that. They're just going to go with the simplest explanation. And in that case, the simplest explanation probably is the correct explanation. To deposit anything else beyond that is just, it's unnecessary. You have a perfectly viable explanation of, you just hit it, went that far, went in the hole. That's it. But when you start approaching, and this is a great way to approach things when science was in its earliest forms. The simplest explanation might be the truest forms. It might be the best explanations. But nowadays, when we see especially in fields like biology, which is the pure complexity of life, when we talk about things like abiogenesis, these concepts are that the simplest answer is, or the scientific answer is not the simplest answer. There is a lot of things that are built into this. And does Occam's razor still have the same type of value in fields, in many scientific fields, as now than it did 600-700 years ago?
Yeah, can I give this a try? So, one place where I can think of where this came into practice for us was, so I work in film and we have a lot of proprietary tools we use, and so a lot of my references or my analogies are related to that. And we actually had a situation where we had an outside vendor, actually it was Intel, and we had a new build of Linux and a bunch of other variables, and we had machine freezes during certain parts of when we were using this certain tool. We would have machine freezes, and we had tracked it down to potentially being one of two avenues, and we actually held off for a long time, and we were limited by what we knew because we were dependent on these outside vendors to investigate their line. But eventually, after a couple of months, we had to move forward on other decisions, and we had to pick a direction and potentially risk being wrong along that line. And as a group, had to discuss which one was had more merit, which one was going to be more likely. But it was to some degree, it was simply based on the variables involved and how much we were assuming and how much of it was what was the simpler one, and we had to try to eliminate one of the choices, go down that path, and potentially risk having it come back to bite us. We might get more information down the road and find out that it's another path. But they did both. It was a really tough one because they both did equally satisfy the problem that we were having. Both were viable. Both had other variables that we weren't sure about. We didn't have any access to that. So that was a practical case I can think of where we kind of had to kind of shit or get off the toilet essentially. So I don't know if that helps.
So I'd just like to maybe say a couple of things. I think historical examples in science often just show that we should have been using it, right? Because when you look back at history, it's a very different thing to being there at the time. So I don't know whether this conflicts with what he's saying, but I can certainly point to examples where people have held scientific beliefs based on authority, not based on evidence. All right. Now, if in those cases, somebody had come along and gone, well, Occam's razor says you should really be looking at this again, then perhaps things would have been better. But people don't. They tend to go, well, Aristotle said X, Y, Z, and therefore we'll believe X, Y, Z, instead of actually going out to test it. Or even in the era of experimental data, I'd point to something like phlogiston and the theory of burning, and say if somebody had just applied Occam's razor there, even they would have got to the answer a lot quicker. But it's just getting to the answer quicker because it's going to make you ask questions. So I don't know whether that conflicts with Ozzy, but there's two real-life examples where clearly we don't use it in the philosophical sense.
With the sense that you just use it, though, the sense that you just use it, for example, the what was the starts with an F again? The theory that everything has a combustible substance to it. That you just brought.
There's a combustible substance in air which allows burning. Yeah.
Yeah. What was that theory called again?
Phlogiston.
Phlogiston. Yeah. I think that's an example where Occam's razor could have failed. I think that could have been put out there as possibly the best explanation out there, or with the one with the fewest assumptions out there. And I think that's an example of that. I think that the more we work into science, where certain explanations just give you nothing but more questions that need more explanations, answer those, that I think that Occam's razor can't really be applied in fields of science the way that they used to. I think in day-to-day propositions, yes, but when actually studying more into science now, I think that's where Occam's razor fails.
I don't know. It's still used in physics theory. I mean, in theoretical physics, quite heavily.
Can we sort of proceed down that line, Simon? Because I think that would sort of become more lucid. I mean, I really like the sort of way that you're going with this, and it would be.
Well, that's just what others have been saying earlier, which is it's about positing the least number of variables to explain the data. It's that simple. If you had to add an extra symbol to your equation, okay, and it doesn't do anything, you just may as well not be there. Right, so you want the least number of symbols in your equation.
It seems like the conflict arises when you ask the question, should it be there?
Or variables. Well, it's variables. So something comes up. You have an equation which explains something like Newton's equations of motion. Something comes up which doesn't quite fit the data. Okay, so you have to start positing other things. And in this case, it's just one other variable is posited to get you to relativity. So that's the simplest way to get there.
So like me adding a cake recipe to your equation for gravity.
If I'd had to posit two things to get to gravity, and there was only one thing I had to posit, one extra variable, then I would go with the one variable rather than the two variables.
Well, I guess I should have said, like, if you have the some equation for gravity, and you're missing one variable in it, right? And I'm just gonna pick some random variable to put in there. I've added on something that does no good for the equation. It has no use there, has no bearing there, has nothing to do with it.
Right.
I
think from my perspective, it's that if there is some data which is not explained currently by an equation which does explain other things, okay, then you could modify that equation by adding another variable to account for the new data.
Gotcha.
Okay, but you might have to add two variables or three variables. You don't know how many you have to add, but the point is you just add one at a time until you can get to an explanation for an observation of the data.
Right.
Conflicting data.
Yeah, like we were saying, it doesn't mean you have to just have an equation that has two variables that explains everything. It might have 50 variables, but that's still that even with 50 variables, and they explain it, that still would be the simplest equation, or the simplest full of variables that explain the phenomena.
Right.
The fewest number. Yeah, the fewest number.
Yeah. Remember, Occam's razor says, do not multiply explanatory entities beyond that which is necessary to explain what you're trying to explain. So if it takes 1,000 variables, 1,000 explanatory entities and posits to explain what you got to explain, then you're good. You're golden. Go ahead. Yeah. It doesn't matter how complicated it gets. But if you're positing 1,001 and you only need 1,000, then the 1,001 you've got a redundancy there that you can eliminate, or you're making one more assumption than you need to make. It's not that the 1,001 theory, or the one with 1,001 variables is wrong, and the one with 1,000 is right. It's that you're making one more assumption more than is necessary.
And by happenstance, the 1,001 still might work.
It might be the right one. It's just that everything else being equal, it's much more, just prudentially, it makes more sense to assume fewer things. There are fewer things where your theory can go wrong. It's just like you're trying to build the simplest machine to explain something. You don't want to have a machine that has more parts necessary. You can have two machines. There's a lot of ways to build a mousetrap, right? But a simple mousetrap is everything else being equal, everything else being equal, going to be the better mousetrap, simply because there are fewer ways for it to fail, right? Your theory can go wrong, right? You can be positing things that don't exist, right? You could be invoking principles that are not operative, right? So the fewer principles you have in your theory, there are fewer ways for your theory to fail, for it to go wrong. And that's why you want to go with the simpler theory. Not because it's more likely to be true, but prudentially, it saves you from positing more things than you need, where everything that you posit is a possible mistake.
So the less things necessary for the system to work is what should be highlighted.
Right, exactly. Do not multiply explanatory entities beyond that which is necessary to explain, right? Or beyond that which is sufficient to explain, is what I should say, yeah.
Can I ask, so in the case where somebody is positing extra entities, they could change their conclusion, right? Like, this is all relative to the conclusion, right? So if you wanted to go down that path, but it's almost a little bit that I use the term of liability, right? You're conserving your claims to what you feel you could falsify, or what you could safely say. And if somebody wants to go, if my friend wants to posit God as a part of something, he needs to balloon his conclusion such that he takes on board premises that then lead to that conclusion. If I'm refining my claim, it's he has kind of one of two ways he could go, right?
Yeah, well, one of the things that happens in connection with God is very often when people are invoking God, they're thinking of God as something that explains an awful lot. You know, you'll say, well, look, you know, God doesn't explain how the universe got here, and they'll think, oh, I think God does explain. Okay, well, let's you know, not beg the question of whether or not positing a God, a creator, actually does any explaining of the physical world around us. But supposing that you grant that it does, okay, supposing you say, okay, well, let's say God has the causal power sufficient to explain the physical world around us, okay, and then you say, but I have a physics theory that explains, you know, these things just as well.
I actually had an example I've been bubbling up to ask, and it's sort of a tongue-in-cheek against ID, but the notion of intelligent falling. So we have the theory of gravity, and we have the notion of intelligent falling. And in what intelligent falling is, it's the act of when something trips or is dropped or whatever, it's actually being pulled down by this deity. The deity is manipulating the matter itself into its movement pattern, and that's intelligent falling. So how do we then say that gravity is the much more likely theory, or is the much more or is the more valued theory over, you know, there being a being that can literally pull them, you know, tug and pull the matter around, as it were?
Yeah, well, what I would say there is that you just have to point out that this particular theory doesn't do a lot of explaining. It doesn't explain why things fall the way they do, as fast as they do, when they do, where they do, and stuff like that, right? Whereas, you know, a theory of gravity, for instance, is going to actually make precise predictions. You know, if I have a theory,
I was going to say that I think that's the difference. It seems I'd argue that it does explain, but it doesn't predict.
Right, but if it can't predict what's going to happen, then it's not explaining what we're going to see, right? An explanation has to include a correct description of what we do see, and it has to anticipate what we will see, what observations we do make, and what observations we will make, right? So it's not an explanation at all if it doesn't. Here's supposing I say there is a force. Okay, I'm going to call this force Quatlu. Quatlu spelled with 3 O's. Okay, and Quatlu is a force that causes things to move. For instance, when I let go of this wireless mouse, it will either fall, go this way, go that way, float in the air, float towards me, float away from me, or just hover in the air, or perhaps spin around in a circle, right? And now I let it go. Oh, it fell. There, my theory of Quatlu is confirmed. Why? My theory predicted, among other things, that it would fall. But look, it didn't actually predict anything. Yeah, it failed to describe what observations we would make. So an explanation is only an explanation when it actually restricts what observations we're going to have. And if it doesn't do that, and it doesn't do it as well as another theory, well, then right there you have another basis. That has nothing to do with, by the way, with parsimony. This has nothing to do with Occam's razor now. This is straight old, look, your theory has to be has to save the phenomena. It has to be empirically adequate. It has to be equal to our observations. It must predict the observations that we make.
See, now I see that seems to be false to me, because it seems to me that we are applying parsimony, because we're saying that it is better to have a theory which predicts less, essentially, or more specifically. A theory that has a specific prediction as opposed to a theory that has a myriad of predictions. So the intelligent falling one would predict that the mouse could go, or the whatever it was, Quaslu, predicts that it could go left, right, up, down, back in time. It's basically got a what they call the chaos drive from I'm forgetting my sci-fi now. Anyway, it basically the theory states that it could do any of these things. It seems that we're then applying the nature, like this notion of parsimony, to our requirements for a successful prediction or a successful explanation.
Okay, but now you're equivocating on what we mean by parsimony here. What we've been talking about all along with parsimony is explanatory entities, right? Not restricting the observations that we're going to make and find, not restricting, not the fewest number of predictions, but rather the explanatory entities. Remember that the principle is don't multiply explanatory entities beyond that which is necessary or sufficient to explain what you're trying to explain. So it's all about explanatory entities and explanatory principles. Okay, what you're talking about now is prediction and description. Prediction and description is way more important than parsimony. It's why, I mean, a theory that doesn't predict or mispredicts or misdescribes, forget it. That theory is off the table. And a theory that does predict and does describe better than another theory, that trumps parsimony any day. I'll take a theory that predicts correctly over a theory that doesn't predict correctly, no matter how many posits the theory that predicts correctly has. A theory that predicts correctly could have 1,000,000 posits. If it predicts correctly, I've got reasons for thinking that those millions of posits and entities are actually real and operative. Why? They predict. They're predictive. So prediction and description, those are what are called epistemological values. They point to the truth of the theory. They are indicators of the truth of the theory. If anything points to the truth of a theory, it's that it delivers accurate observations, both present and future observations, and retrodictions, observations that we would make about what happened in the past. So description, prediction, and retrodiction are really strong epistemological values that absolutely trump a pragmatic and prudential consideration like Occam's razor. Anyway, I hope that makes the distinction there.
Can I just say that? I mean, I agree with absolutely everything said there.
Okay, here, Quantum, you go just a second. I'm going to open this up to the public for the last 15 minutes or so, and go ahead and make your comment, and then obviously afterwards we'll have the after show that people can make that. But I think there's people in the audience that might have some opinions on this, and like I said, we've got 15-20 minutes before I'll wrap everything up and give you all closing comments.
Can I just make a point, because people are going to think that I was arguing against Occam's, because I've been really unclear in the middle part of the hangout, and people are going to think that I was arguing against Occam's razor, which isn't the case. I agree with everything that Ozzy just said, by the way. That he expressed it perfectly, and with regards to the example that Alex made about the the intelligent falling versus the Newtonian thing. When considering this extra variable, what do you call it, quasimodo or something? You put in this extra variable, so you have this degree of irrelevancy, this degeneracy that makes your theory not compatible with Occam's razor in a sense. But like Ozzy pointed out, the predictive power of a theory is more important. So my view on this is essentially you've got to have a theory that's predictive. But when you construct your theory, what you want to do is you want to construct it with the lowest degree of freedom possible that still fits the data. That's essentially the whole point I've been trying to make all along, and I think this is the best interpretation of it. When you're constructing a theory with the lowest degree of freedom possible, that will only give you the bare minimum, the necessaries for the theory. It won't give you anything extraneous. Positing some sort of third variable that adds absolutely nothing to the theory it is in contrary to this Occam's razor, because again it adds absolutely nothing to it. It doesn't contradict it, but it adds nothing to it. But the point I was making, and I think this is why people are going to perhaps maybe suggest that I was arguing against it and I wasn't, is that it's a little. I think it's very dangerous to say that Occam's razor is about simplicity. I don't think it's about simplicity per se. I think it's more about degrees of freedom. And the example I gave earlier regarding the two theories, one being more complicated and one being quite simple, and both of them work quite well, and the kind of a paradox where the theories tend to get more and more complicated as we go along. So I think I more or less agree with everyone here about that, and I think Simon found a very good way of putting it. Anyway.
Yeah, so I think I just want to say a quick wrap-up as well, if I may, and thank Ozzy for explaining a couple of things in the middle there. I was kind of doing the same thing. I was trying to be devil's advocate in some respect and ask questions rather than, just say whatever. But, yeah, so I think the simplicity thing is definitely the point that most people confuse on the basic level. And I think the philosophical side of the argument I would like to go into more in future. I think I'd really like to be able to answer why we can or cannot use it in that debate the way that I would wish to use it, which is obviously to disprove or say the more likely outcome is no God. So for the next show, I think that's where I'd like to the question I'd most like answered. Thank you.
Hey, Scott. Welcome. If you had a quick comment, I was actually just going to have people write them on the side, then address them. But if you had a quick comment or criticism you want to add to this before we go to closing comments, please bring something up.
I have a question. It's sort of basically a question of if this is an example of actually like sort of applying Occam's razor. When I'm encountering unexpected behavior in a program, one of the strategies, and it's usually sort of a last resort because it can take a lot of time, but it's sort of the way to really cut to the heart of what's causing the problem is to pare down everything to its absolute bare minimum, and once you have it at the minimum state in which it is behaving correctly, to slowly, just piece by piece, add it back in. Is that sort of a practical application of using Occam's razor to sort of analyze a problem by just removing all the complexities and then adding them in one by one until you replicate whatever isn't working? Does that make sense?
That sounds closer to, from my own understandings, that sounds closer to anti-razor, where you are taking where you haven't got your conclusion yet, where you're trying to reach your conclusion, i.e., a stable program, and you are adding in every you know that there is at least one more necessary step to add in to reach the goal, as it were. Or I might be confused with that, but I think that's right.
I think it's actually a good example because
Yeah,
a very, very crude way that you could measure degrees of freedom, a very, very crude way you could measure it, is in terms of information. If something's got more information, it's presumably got more degrees of freedom. So if you have a 20 megabyte program and you have a 10 megabyte program, and they both do identically the same thing, then obviously the 10 megabyte program is going to be, you'd want to use that over the 20 megabyte program because it uses less space and so on. It performs the task more efficiently in terms of the amount of space it uses, so you'd go for that one. There's essentially 10 megabytes worth of specious code that you don't need, so you'd go with that one. So I think it's quite a good example.
Yeah, I think Scott's example is a good one. Also, here's another example that you could use. Supposing that you suspect that you have some kind of food allergy that's causing you some kind of problem. You know, you're having some kind of dietary issue or something like that. And so you go on what's called a restriction diet. You eliminate a bunch of things from your diet, and you're living on bread and water for a while, for a few days. But you've eliminated everything from your diet, and then you talk to a doctor or nutritionist, and you say, okay, and your doctor or nutritionist says, okay, we're going to reintroduce things. We're going to reintroduce milk, and then we're going to reintroduce eggs, and then we're going to reintroduce fruits, and we're going to reintroduce one thing at a time until finally the symptoms come back, right? So we put you on an elimination diet, the symptoms go away, you have no allergic reactions, and then we're going to reintroduce one food type at a time until finally you come back. Now, what are you doing there? Well, that is in a way applying Occam's razor in a stepwise set of iterations. You're just reiterating, right? What you're trying to do here is you're trying to say, okay, what will explain the symptoms that I have? You're trying to explain why the symptoms arise. Okay, so well, let's posit that it's bread and water. So you go on a bread and water diet. Nope. Bread and water doesn't cause it. Okay, bread and water is not sufficient to explain the symptoms. Okay, let's add milk. And you add milk, and then nope, bread and water and milk is not sufficient, and you keep going, right? So this kind of thing, and the kind of thing that you described with code, is exactly the same. Is the same kind of thing. You are in fact applying. These are just iterations of Occam's razor. You're comparing one theory against another theory. The theory that bread and water will induce an allergic reaction. The theory that bread and water and milk and eggs will introduce the allergic reaction, and so on, right? At every point is theory choice. And actually, Quantum brought up something interesting. When he's talking about degrees of freedom, especially in the context of formulating a theory, we often are applying Occam's razor when we devise and develop a theory, not just when we have two theories that are already out there, published and to be evaluated, to be compared and tested, and then when the testing is ambiguous and inconclusive, then we apply Occam's razor. It's not just then. We also are applying a principle of parsimony when we are creating our theories. I'm going to create this theory. I'm coming up with a theory. Okay, well, I think I'm going to posit that I'm going to come up with an equation that posits these sorts of variables. Time and distance and gravity and density and mass and all these kinds of things. So temperature, pressure, all of these things go into your equation, right? And then you go, well, wait a minute. Actually, I can think of another equation. Supposing I left out pressure, right? Could I still predict? Would I still get the predictive results, the right results, using this equation that posits fewer entities, that doesn't invoke the concept of pressure, for instance, right? There you are in fact applying the principle of parsimony as you are formulating your theory. So the principle of parsimony is not just involved in comparing two extant theories, but also when comparing two theories as you're making them up, as you are formulating hypotheses and theories, you can apply Occam's razor. So it happens even at the stage of theory development, not just at the stage of theory choice after the fact of theory development.
Cool. That very much answers my question, and is pretty much. I think that the short answer is that yes, that is applying Occam's razor. It's just doing it from the front rather than after the fact to analyze.
Right. Right.
Cool.
I mean, I think in the practical sense, the point I was trying to get across is that it's vitally important to do it in the theory development. I just can't really think of a choice where it happens in the other case. And
well, I mean, if every scientist were to apply Occam's razor at the stage of theory formulation, there are going to be fewer instances of theories that are out there with redundancies in them, or theories out there that both explain the phenomena equally well, but one has more assumptions than the other, right? So you can sort of avoid that condition by applying Occam's razor during the stage of theory formulation, right? And I think that happens a lot more in the physical sciences, especially the physical sciences where you have mathematical equations that are heavily involved, like physics and chemistry, for instance. Because in an equation is just a description, it's not an explanation. But an equation incorporates within it variables, right? Things like temperature and pressure and mass and density and all of these things. Those are all theoretical entities, right? Incorporated in an equation, although an equation is just a description, it implies an explanation. There's a whole ontology. There's a whole theory of causes and operative principles that undergird an equation, right? That are what an equation is describing. An equation is a description of a set of relationships between theoretical entities, right? So it's actually better if all of that is happening at the stage of theory development and formulation, and not done after the fact. But of course, after the fact, then you have to, you can apply Occam's razor then.
Well, hey guys, I think it's been a great conversation. I mean, I still might think we might do a part 2 and get a little deeper into it, even though we got really deep into it this time on the physics and on the philosophy side. But I think it's about the time to start wrapping it up. And if y'all want to start making closing remarks, we can start on my screen on the left end and start with Alex. If you had any closing remarks there you want to make.
I just want to say thank you for inviting me, and I wish I had more to contribute than just asking questions, but this has been really fascinating, and yeah, hoping for a part 2, and thank you very much.
Yeah, great. I think so too, and I didn't know too much coming into this either. And, yeah, if I pass it to Bert, if you had any closing remarks on that, or closing thoughts.
I'd echo what Alex said, and I thank the panel for their patience with me. My first time hanging out with you guys, and thank you so much for having me.
Yeah, thank you so much. I'm glad that finally got to get to hang out with you. So, and Ozzy, did you want me to go to you now, or did you want to go last?
No, there's no reason why I need to go last.
Okay, great.
Just one little thought. We were supposed to talk about sort of misapplications of Occam's razor, and one that I hear all the time is when people are talking about sort of ultimate explanations of, why is the universe here? Why is there something rather than nothing? And some people will posit a God, and then an atheist will come along and say, well, no, I just think there's no God. I think the universe just is, just as a brute fact. And then they'll invoke Occam's razor and say, see, this is a simpler explanation. Well, wait a minute, though. Occam's razor is supposed to be comparing two explanations of a phenomenon. When you posit that the universe just is without an explanation, that's not positing an explanation. That's precisely when you cannot invoke Occam's razor. Okay? So if you have an explanation for why the universe exists or why anything exists, that's great. You can put that up against positing a God as an explanation. But don't go invoking Occam's razor as some kind of trump card against positing a God as an explanation when you just think the universe exists as a matter of brute fact, which I think is very likely true. But that's not an explanation. And so you can't invoke Occam's razor there. So that would be an instance of misapplying the principle of parsimony. You can only invoke the principle of parsimony or Occam's razor when you are comparing two theories that purport to explain a set of phenomena or a phenomenon, not when you're not explaining, not when you're just saying something is a brute fact. Anyway, thank you very much. I thought this was a useful hangout and a useful discussion. Thank you very much for inviting me. I look forward to part 2.
Yeah, it was great. I loved the input, and I wish we had have gotten more to exactly what you were saying. And I apologize to part of that. I thought I was muted and talking to my wife about dinner. So I think it all came through though. But okay, yeah. Quantum, did you have any closing thoughts, closing remarks you wanted to add to that?
I just want to apologise for my sort of speaking tone, because I know I stutter a lot and I'm trying to avoid that. But I know I'm very bad at speaking lucidly, and I'm trying to improve. So I would appreciate it if people could sort of. I know I'm going to get a lot of things in the comments, because it tends to happen when I say something slightly controversial. But I'm happy to respond to any of it, and I think it came across like I was disagreeing with people more than I actually was. I was disagreeing on quite minor points, but because I'm quite bad at I'm quite bad at vocalizing my disagreement. What tends to happen is that I often go around the point and other people go around it, and that's a flaw in my speaking skills more than anything else. So that it may come across that I was disagreeing more than in practice I actually was. So I'll happy to explain anything in the comments about that, and I apologise for my speaking skills. I'm trying to improve on that.
No, I'm terrible at articulation too. I think this is the first time that I've actually kind of felt good about hosting. So no, you came across great. I thought you were a good voice and a good add to this. So
yeah, likewise.
And Scott, if you have a closing remark, that's fine too. I know you weren't here through the whole time, but if you had something you wanted to close on, because you added a lot there at the end.
Well, I appreciate that. I don't think I have a lot to say. I've been listening most of the time, and I think this topic has been well covered. And I like Occam's razor, and pretty much for the reasons that Simon said, it's a good way to prioritize what you look at. It's not. I have seen it horribly abused as like the fiat. Oh, it violates Occam's razor, so therefore it must be wrong. But I would say that using it as a means to narrow down what you look at is, I feel, probably one of its best uses.
Yeah, right on. I agree. And if you're there, Simon, did you have any closing thoughts you wanted to add into this? Not sure if Simon's still here. Okay, I'll come back to you, Simon, see if you're still here. And Sokka, you were here through most of it. Did you have anything you wanted to add, close on that?
Yeah, I guess just one more point I just want to clarify. I guess because Dinah Cat loves me. I love that name. Sorry. Pointed on the comment section. And I think that I just want to reiterate it as well. Is that when we're talking about Occam's razor, it's what he put about there is that the most important part of Occam's razor are the words "all things being equal." And that is kind of an important part to it. Is that when you're forced to decide between different hypotheses or different theories approaching a problem of some sort, that if it only yeah, we can hear you, Simon. That Occam's razor is used when both of the theories do seem to be equally valid. That's when you're using it at that time. And I think that it was kind of implied that that we were saying that, but just to clarify, I just wanted to point that out again. But other than that, I don't have much to add.
Okay, great. Yeah, and now that your mic's working, Simon, if you wanted to add a few closing thoughts.
Cool. Okay, is my volume okay?
Yeah, perfect.
Excellent. Well, yeah, I hate to go away on a total agreement. That's just me, bit of a contrarian. So I just want to say I disagree with everybody. Occam is spelt Ockham. Thank you very much.
And a tribute to your contrarianism. That's how I labeled the title. So. Okay, great. Then I, on my personal opinion, I think this was a great show. Like I said, I didn't know too much coming in, just the basics of it, and y'all have opened my eyes to a lot of it, and I think I'm sure to the audience as well. And I do hope we do a part 2, and I do hope we get into misuses of it and a little deeper into using it, whether it's the philosophical side or the physics side or any type of scientific side. So I want to thank you guys for being here, and thank all the audience that's out there watching. We love you, and y'all have a good night.
Night.
Oh, and one more quick thing is our after show will be on the Xbox Fiend channel, the Xbox F, and we'll see you there. Thanks a lot.